So domain and range have to do with x's and y's in a relation. So let's say, for example, you had a relation that was a bunch of points. So 1, 3, 5, 6, and 7, -2. Okay, a bunch of points. So that's called a relation. If you put them in these squiggly brackets and commas in between, that's called a set of points. So we're going to be using the squiggly brackets called set notation when we talk about domain and range. So let's say I have a relation like this. So it says in the box, the domain is the set of the first elements in a relation or function. So the first elements of all these points are the x's. And the range is the set of second elements. So those are the y's. So if I wanted to write my domain from this relation here, I would say that the domain is equal to the set of numbers 1, 5, 7. So those are all the x's. And the range is the set of numbers 3, 6, -2. Okay, so those are all the numbers that are in the second element, the second part of the point, or the y value. And actually, to be mathematically nice, we order them from smallest to greatest. So I'm going to rewrite my range as -2, 3, 6. Okay, so that's how you would write domain and range when you're given certain points. So for this worksheet here, there is a graph provided, and it's asking us for the domain and range of this graph. So this is a circle, and the domain is going to be the set of all x values that have points on the circle. For example, if I say, all right, if x is 1, is there a point on the circle that has an x coordinate of 1? And the answer is, yeah, sure, there's one here, and actually there's another one here. By the way, the fact that there's 2 points, 2 different y's, when x is 1 means the circle is not a function. It fails the vertical line test. Okay? But what other points are on the circle? So -3 and -4, those are all on the circle. How about 4? So 4 is out here, is not on the circle. So we say that 4 is not in the domain of the circle. So which x's are in the domain? Anything from -6 until 2. Okay, so we're going to write that in math terms. So here is, they've started for you the domain and the set notation, so I'm just going to complete it. I'm going to write out the symbols, and then we're going to write it in English underneath. Okay, so the domain is, and then you open the bracket, so that's the set of all x's. Now there's a bar. I'll explain what that means. Then we're going to write x is between -6 and 2. Here's how we do it. We write x, we write -6, and we write 2. And in between them, there are these less than or equal to signs. If you read this, starting from the x, going to the left, it says x has to be greater than or equal to -6, which is true. X has to be greater than or equal to -6 to be on the circle. And if you read the other part, it says x has to be less than or equal to +2, which is true. X can't be greater than 2. And then there's a comma, and then there's this symbol here. So what I'm drawing, x, and then there's this round E, looks like this. And then there's this R that's got an extra bar in front, like that. So please write that, and then I'm going to show you what all those symbols mean. So underneath, we're going to write what this sentence means in English. Okay, so this D is the domain. Okay, so you're going to write this. You can pause the video at any time to catch up. So if you want, listen to it once and then go back and write it in. So the domain, the equal sign is. The domain is. Then we have the squiggly bracket, which it means the set of. And then the x is all x's. And the bar is read such that. So such that means there's a condition coming. So let's read it so far. The domain is the set of all x's such that. That means now there's a condition. We read this as x is between -6 and 2. So that's the condition. X has to be between negative 6 and 2. This comma is and. So there's another condition. And this last part here says X is an element of the real numbers. What does that mean? So the real numbers are a set of numbers that you could find on a graph or on a number line. So 1 and 2 and 10 and -5 and -5.1 and 1/5 and even pi. You can find them somewhere on the number line. What is not a real number is this number. Okay, we can't graph that. We can't find that on a number line. So as long as it's graphable and it's between these two values, then that X is in the domain. Now we read it all together. The domain is the set of all X's such that X is between -6 and 2, and X is an element of the real numbers. That's a complete domain sentence. Now when you're working with domain and range, you're not going to memorize little symbols and not know what they mean. You're going to say the entire sentence in English so that it makes sense. And we're going to do that every time. Okay, let's write the range statement. So range is going to be the y values. The lowest the y can be is -1, and the highest it can be is 7. So y is going to be between -1 and 7. So let's write it. I'm going to say it in English. The range is the set of all y's such that y is between -1 and 7. So look how we're writing it. The -1 first, it goes in order. -1 first, then the y, then the 7. Okay, so y is between them, and y is an element of the real numbers. Okay, so that's the domain and range sentence. I'm going to do an example from below real quick. This is a parabola. Okay, you can see the arrows. I've extended them a bit just so that you know they go on forever, right? And as the parabola goes up forever, it also goes from side to side forever, which means if I want to write what's the domain, what are the x values that have points on this parabola, I could pick any of these, but I could also pick something out here like 1,000. If x is 1,000, you will have a point on the parabola because eventually this one will go so far out that it will reach 1,000. So the domain actually has no conditions other than it's really all x's as long as you can find them on a number line. So the domain is the set of all x's such that x is an element of the real numbers, and that's it. No other condition. But that's not the same for range, because as you can see, the lowest the y's can be is -6. So there is a condition on the y. So the range is a set of all y's such that y is greater than or equal to -6, and y is an element of the real numbers. Okay, so depending on the picture, it might be, you might have to change the way your domain and range is written. I'll remind you that a closed circle means the point is included, and an open circle down here means the point is not included, which means if I wanted to do the domain of this one, this is -7, x has to be greater than -7, but it can't be equal to -7. So you're going to write the domain is a set of all x's such that x is greater than -7 without this greater than or equal to, because it cannot equal -7. Okay, so please practice. The solutions will be online. Thank you.